Dear chemistry students and friends, Assalamu alaikum. You are watching NPTEL Chemistry e-classes and I am your chemistry detective with solution of one new NCERT chemistry class 11th problem. So our problem is calculate the atomic mass of chlorine using the following data. Chlorine exists in nature in form of two stable isotopes, chlorine 35 and chlorine 37. We are given percentage natural abundance of chlorine 35 isotope as well as chlorine 37 isotope. We are also given molar mass of chlorine 35 isotope and chlorine 37 isotope. And now we have to calculate, using this data, we have to calculate the atomic mass of element chlorine. This problem is based on the idea that if an element exists in nature in form of two or more stable isotopes, each isotope has its own relative atomic mass, which is a whole number. For example, here chlorine element exists in nature in form of two isotopes, chlorine 35 and chlorine 37. Each of its isotope has its own relative atomic mass. For example, relative atomic mass of one isotope of chlorine is 34.9689, approximately equal to 35, and relative atomic mass of second isotope of chlorine is 36.9659, approximately equal to 37. Now question is, what is the relative atomic mass of element chlorine? Will we take relative atomic mass, should we take relative atomic mass of element chlorine 35 or 37 or any different value? And idea is that for any element which in nature exists in form of two or more isotopes, each of its isotope has its own relative atomic mass, but the atomic mass of an element is the average of relative atomic mass of all its isotopes, and this concept is named as average atomic mass. So remember guys, that for those elements which in nature exist in form of two or more stable isotopes, each isotope has its own relative atomic mass, and atomic mass of such kind of elements is termed as average atomic mass, because it is equal to the average of relative atomic masses of all its isotopes, and is calculated using this equation. Equation is average atomic mass of an element is equal to percentage abundance of isotope 1 multiplied by its relative atomic mass of isotope 1 plus percentage abundance of isotope second multiplied by relative atomic mass of isotope second. divided by 100. Average atomic mass of any element which in nature exists in form of two or more stable isotopes is calculated using this formula. On RHS side, I wrote percentage abundance of isotope first multiplied by relative atomic mass of isotope first plus percentage abundance of isotope second multiplied by relative atomic mass of isotope second divided by 100. So, for each isotope we have to calculate product of its percentage abundance and relative atomic mass and add these numbers for all the isotopes, divide it by 100, we will get average atomic mass of an element, and here element is chlorine. Therefore, we will calculate average atomic mass of chlorine will be equal to percentage product of percentage abundance and relative atomic mass of chlorine 35 plus percentage abundance multiplied by relative atomic mass of chlorine 37 divided by 100. Or else you can convert percentage abundance for each isotope into fractional abundance. You can express percentage abundance of each isotope in terms of fractional abundance simply by dividing percentage abundance by 100. For each isotope you have to divide its percentage abundance by 100, you will get its fractional abundance. In that case, average atomic mass of element will be equal to sum of products of fractional abundance and relative atomic mass of all its isotopes. Since in this question fractional abundance is given in terms of percentage, so I used this formula in terms of percentage abundance. If in any other question you are given fractional abundance, then there you have to use fractional abundance of each isotope. That time you need not to divide by 100. Now I will substitute the values. Percentage abundance of isotope 35 is 75.77. Its relative atomic mass is 34.9689, approximately equal to 35 plus percentage abundance of isotope second is 24.23 multiplied by its relative atomic mass or molar mass, which is 36.9659, approximately equal to 37 divided by 100. And I have already evaluated this RHS side, it comes equal to 35.5 approximately. Average atomic mass of chlorine is equal to 35.5. In question, we are provided data for element chlorine, that it has two stable isotopes, chlorine 35, chlorine 37. Percentage abundance of both isotopes was given, molar mass was given. Now we are asked to calculate its atomic mass. I said this problem is based on idea of average atomic mass, and average atomic mass is used for those elements which in nature exist in form of two or more stable isotopes. Each isotope has its own relative atomic mass, which is whole number, and atomic mass of such element is equal to the average of relative atomic mass of all its isotopes, and is calculated using formula that average atomic mass of an element is equal to summation of products of percentage abundance and relative isotopes or relative atomic mass of all its isotopes divided by 100. And I told, if instead of percentage abundance fractional abundance is given, then average atomic mass of an element will be equal to summation of products of fractional abundance and relative atomic mass of all its isotopes. And for chlorine, when I used this formula, I got that average atomic mass of chlorine is 35.5 approximately. One more difference you can observe, that for such elements relative atomic mass of isotopes is whole number, but average atomic mass of such element may come equal to fractional, like in chlorine, because chlorine, one of its isotope has relative atomic mass 35, which is whole number. Another second isotope has relative atomic mass 37, which is also whole number, but average atomic mass of chlorine is 35.5, which is not a whole number, which is fractional number. Thank you. This is what I have got for you in this short session. Take good care of yourself. See you tomorrow with one new chemistry problem. Allah Hafiz.